Hello, welcome. How are you? Hope you are enjoying my videos on dynamics. This is the seventh of the series. Uh, Briefly, I'll try to give you a recap. Last time we did pulleys and tension, and that is not yet over. I was telling you how to write the constraint equation at the beginning before even you write the dynamics, because constraints are nothing but kinematics, and it's an interrelationship between the movement of one body with that of the other that are connected or linked. So unless you establish that and make it a point to write that equation first, do not try to attempt even applying Newton's second law and the dynamics, right? So I was trying to give you a few multiple pulley cases. I think you have already done that. Now I'll give you another case. You look at that. Likewise. I'll come back to that. First, supposing so far we have looked at cases which are moving either vertically up or vertically down. Now suppose there is an angular movement rather, not in the direction of the string but maybe at certain angle. Supposing if I take this angle as theta, as this moves up, this will go down. Now one thing is, you can take your x, y and then do in your conventional way. That is one way. You can still use your two-finger technique. How? Now for example, if this is V2, in the direction of the string, what is its component? Say for example, if this is theta, this is theta, and this is 90 minus theta, alright? Now V2 cos 90 minus theta, that is V2 sin theta. Now I am not interested in the other component. Along the direction of the string, does the segment increase or decrease? Previously, whatever you did, they were vertically up, down, so there was no issue at all. I didn't make a mention of that it should be taken along the string, because anyway you were taking it, so I didn't mention. Now you see, now it's very simple. Once you get this is fixed one. Now as before, likewise, so segment is increasing. So I put it as plus V2 sin theta, and this is segment decreases, you could see minus V1 is equal to 0 or V1 is equal to V2 sin theta. Now one important thing here, don't try to differentiate and get even here. because even here is no problem, is a product formula. Theta is a variable. So you use product formula, get A2 sin theta plus V2 cos theta d theta by dt. So it's going to be a little complicated. So whenever you have arrangement like this is how you have to take it. In the direction of this string is very crucial. Okay. Now I'll show you another example. This is L, this is L, this is all fixed. This is body number 1, this is body number 2. Now once you release it, it will come and then hit it like this. So once it is about to hit, this body would have come up like this. Okay, if say this is A1, this is A2. What is the relation between A1 and A2? I am only worried about the constraints, nothing else. Now, if this is A1 in the direction of the string, presuming that this angle is theta, this angle also is theta. So, for this is A1 cos theta. Now, what is happening? You see, plus A1 cos theta, here minus A2. I hope you have got this. So, for A2 is equal to A1 cos theta. Now, what is cos theta also you can do. This is L, and you know that this is also, because this is fixed to the string. So, this whole thing is 2L length, this is L, therefore, this is under root of L square plus 2L whole square. What are you getting? So, cos theta is 2L by L root 5, or cos theta is 2 by root 5. So, this is the relation between A1 and A2 in this case. So, wherever you come across such kind of modes, I am again telling you, I am not putting dynamics here, putting only constraints, that too pertaining only to the strings. So, hope this problem is clear to you. Now, look. Yeah. This is V3, this is V2. You know, both are supposed to go with same speed or same velocity, so that it will go along this line. If this is more, this is less, there is a tendency for it to go, so it doesn't follow that. So if I'm taking a specific case, at one instant, let this angle be theta, and it is going up with the V1. So, along this, what is that component? V1 cos theta, okay? So, what do? Minus V1 cos theta plus V2. It is symmetric on this side, therefore V is equal to V1 cos theta. This is how you have to obtain. Wherever you get it out, you take from the fixed point X and Y. You can do that, there is no problem. Suppose if I am taking it as Y, this as D, etc. This is nothing but root of Y square plus D square. The root of Y square plus D square, you try to differentiate that. And once you get that, dy by dt is your V1. So that you can write down those equations. And cos theta you are getting here. The cos theta you can substitute in terms of cos theta is y by root of d square plus y square. Okay. Now the question is this, if I take it as S1, this also as S1 total, we'll take it as S2. I told you both will have to move with the same thing. And this is, so you get root of d square plus y square, another d square plus y square plus 2s2 is the total length. Now this is what you have to simplify. So when you differentiate, this becomes 0. 2 will also go 1 by 2 root of d square plus y square. What is y square derivative? 2y dy by dt plus s2, we will call it as v. This 2 gets cancelled. This is nothing but your v1. So I write v1 y by all this. So y by all this is cos theta plus v is equal to 0. This plus minus you don't bother. As I told you, when you do like this, you will get everything down or everything up. That's where you got it. So this is the same relation we got even before. So whichever way you want, you can do it. Okay? Right. That leaves us with, there is one case I am trying to put. One, two, three. Remember, look at this single row. Only one constraint relation you get. Everywhere tension is T because light rope and this is light pulley and masses. It has its own mass, but still we take, because there's no friction, we'll take tension to be the same. Now how do you write it? Suppose I am taking it as A1, A2, all downwards, right? How many segments are there? 1, 2, 3, 4, 5, look, 6 segments. Write for each one, starting with 1. This is fixed, so this is plus A2. That is 1, 0 I am not writing. 2, plus A1, 0. I am writing here plus A1. This is also plus A1. The other one is 0. And here, 0 and plus A3 over 5. Minus A2 plus A3. Got this segment? Minus A2 plus A3. How many you got? Yes. And then what about the fifth one? We didn't do it. Now you look at this. Minus A1 plus A2. Alright. Minus A1 plus A2. The whole thing must be equal to 0. See, if some things do cancel out. And then there is A1, A1. That leaves you with A1 plus A2 plus A3 plus A3. This is the constraint relation. Now, how do you write the dynamic relations here? I'll do FBD here itself. And this is M1G. All downwards, therefore, T plus M1G minus T2, T is equal to M1A1. This is over. This one. T, M2G. M2G plus T minus 2T is equal to M2A2. Here, T, M3G. One, two, three, four. The equations A1, A2, A3, T, 4 variables. Now I think you can solve it. So whenever you see the diagram, don't get perplexed. Just look at how many ropes are there. And now each rope will have its own constraint relation. Coolly sit down and write, you will get the answer. Okay? Right. Now, we saw quite a few cases of these pulleys and constraints and the tension. So, I'm now very sure that pretty sure you can work out most of the problems pertaining to the pulleys and strings. So, for example, if I have a heavy rope and a mass attached to that, the mass of this is L. Now, let me presume the whole thing is accelerating up. Now they may ask, what is the tension there? What is the, suppose this is X, what is tension there? Tx, this is how they may ask. Now, as I have said before, you can easily convert this into multiple body system without going for integration here. Because there is a discrete body, it is not preferable to do integration. So what is this? I will visualize this as a light rope, tension T0, with a mass x lambda. Another light rope with a mass. Now this is M1, M2, totally is M. Again a light rope here. This is M. Look at that that body I brought into this with the 3 light ropes where I can find out maybe A, you may like to know what is tension at A. I will call it as Tx, I will call it as Ta. Now the rest is very simple. Draw FBD for each and everything. Automatically you will get the answer. How? You said the whole thing is accelerating up. Therefore, look at this FBD. Now you have Tx there, T0 there. It's accelerating up. So T0 minus Tx minus mg x lambda g is equal to ma. Because the whole thing is accelerating. Similarly, come to this. Tx minus Ta minus L minus x lambda g. That's the mass I'm putting in terms of lambda. Lambda is linear density, you know that I've already defined. So you've got. Now what about third equation? That is also accelerating up TA minus mg is equal to ma. That's it. Now how many variables? A is known here. He has given it. So A is known. T naught, Tx, Ta. Three equations, three variables. You can solve and this is a very, very simple way to work out. In fact, if you sum up all, you can see Tx gets cancelled, Ta gets cancelled, and here x lambda A gets cancelled. So what are you getting? T naught. Now this whole thing becomes mg. This becomes mg. This is put together L lambda A, that is ma, plus capital M. So T naught is equal to m plus m into g plus e. Once you know this, find out what is Tx and what is T. Both you can find out and get the answer. You got the point? Right. Now, any such a problem you can do in this fashion. Now, if you recall, what is it that we try to do in all these exercises? When I said I am going to discuss tension, I was looking at the light ropes and heavy ropes. Light, I said the tension remains same everywhere except when it passes over a rough and heavy pulley. Otherwise, the tension remains the same. Otherwise, you are supposed to take tension to be different on either side of the pulley. And then we looked at a heavy rope. If the density is a variable density, constant mass, constant density, all possible cases we derived, we got the tensions. And then we were looking at the pulleys, so we landed into constraints. So what about these constraints, how to do that, etc. Now this is very important, right? Now, for example, I take an Atwood machine, M1, M2. Suppose this will accelerate down with A. This will, we know, we have already derived that. If that is the case, A will be M2 minus M1 this. T is equal to, so this is a standard way of writing for any Atwood machine where the pulley is fixed and the thrust on the pulley, be careful that here it is going to be 2T. Thrust on the pulley, I made a mention of that. I'll give you a few examples for thrust. Before I forget, I want you to take note of this. First I am doing here. T, T. So thrust is 2T. Now for example, this is T, this is T. Now this angle is theta. How do you see? What are you doing? You are getting a vector sum of these two. This is T, and what is this angle theta? So how much do you write like this? So T square plus 2T square cos theta. You got the point? Or what else you can do, I'll tell you. If I resolve that there, it becomes T sin theta. If I resolve it here, T cos theta. So this is a T plus T into 1 plus cos theta. This is T sin theta. Now T is common. 1 plus cos theta whole square plus sin square theta. Now what do you get? 1 plus 2 cos theta. Sin square theta plus cos square theta is 1. So you will get 2 plus 2 cos theta, or 1 plus cos theta is 2 cos square theta by 2. I think in the vector notation when I was discussing, I have probably given you this. I hope you are able to get this point. What is cos theta? You can write cos square theta by 2 minus sin square theta by 2, or this is 2 cos square theta by 2 minus 1. Okay? So, if I take 1 plus cos theta, you can write it as 2 cos square, 2 into 2, 4 cos square theta by 2. Therefore, this is, so you can always take this as the, provided the tension is same on both sides. So, 2t cos theta by 2 is a general expression for the thrust. For example, if suppose this is T, this is T, this is T, this is T, thrust on this will be 4T. Because it has taken one round and second round, likewise you have to be careful, remember. So the thrust here is 4T. The other side of the coin could be, this is T1, this is T2. What do? Angle is theta. Simply mod of T1 bar plus T2 bar. What do you do for that? T1 square plus T2 square. That's it. Whenever they ask you thrust on the pulley, this is how you have to do it. Is that okay? Right. So, going back from thrust for the pulley to this, say it accelerates like this, you got it. That is fine. Suppose after t1 seconds, this will come down like this. Remember, whatever amount by which it comes down, same amount it goes up. And the displacement, magnitude, the velocity is here, the acceleration magnitude, velocity magnitude, all are same based on the constraint relation. Now at T1, what is the, suppose if it is released from rest, what is the velocity here? AT1. This is also AT1 is the velocity. Fine. Suppose I stop it momentarily and release. So that means I am not losing much time. I am stopping it here and immediately releasing it. See, the moment you stop it, this tends to get slackened, but you are releasing it. So tension is lost. So this is a very important point. The moment you stop release, it continues to move. The tendency in that infinitesimal time, this tends to move, and this string tends to become slackened. If you hold it for a while, it could have really get slackened. But you are immediately releasing it. What does it mean? That wire may be straight, but it loses second. Tension becomes zero. So momentarily stop and released. What is the further motion? What's going to happen? Now, this continues to move up as though this body is projected up with the AT1 initial velocity. And this, the moment 0, it starts moving down under gravity. So both will move under exclusive influence of gravity. So how long this moves? Till its velocity becomes 0. Let us say it will become 0 in time t2. Let us see what is the time of ascent. There's nothing but time of ascent. Is equal to u by g. U is 81 by g. T1 is given to you. In the same time t2, what is the velocity here? 0, t2. So v is equal to at. That is g t2. You understood this point? gt2. And if you take at1, that initial velocity will also become gt2. So the velocity here, there is a downward motion at that instant just after t2, and here this momentarily stops. It doesn't move, momentarily stops, whereas this continues to move. So this will try to pull it up. So the string gets taut at that instant. The string gets tight at that instant. I repeat this. The moment you release it here, stopping and releasing, it will move under influence of gravity in time t2. It goes on getting this velocity. But this velocity goes on decreasing and becomes 0. At the instant when it becomes 0, what is the scenario? This will have a tendency to come down. This will have a tendency to come down with certain velocity. So, because of both are trying to pull it down, the rope becomes taut. You get the point? The rope becomes taut and it gets tight, and then it starts moving again with its own acceleration as before. Right? So, at what time this thing becomes, taut again, you can work out T1 if it is given. Say, what is A? You know that this is A. So, the T2 will be M2 minus M1 by T1. So, after a time M2 minus M1 by M2 plus M1, string gets taut again. I hope this is clear to you, right? Now, suppose I take an elevator or a lift where M2, M1, let me presume the whole thing moves up with acceleration. Okay, the whole thing moves up with acceleration. How do we write it here? What is the tension? What is the thrust on the pulley? Everything I want to know. Now, when you draw that FBD, as I told you, the whole system is accelerating up, so I can make use of the pseudo force technique. There must be an additional force, so I'll be getting that. And here the tension is T. And let me presume that it is moving down with a relative acceleration. With respect to this, it will come down. Therefore, with respect to this, it will go up with same magnitude of acceleration. Therefore, you have, in a similar way, if you write for this, because this is going up, by analogy I am writing M1JR That's it. So, if I want to eliminate, multiply, this is m1 m2 into g plus a minus m1t is equal to m2t minus m1 m2 into g plus a. You bring this onto this side, this onto this side. So you get m1 plus m2 into t is equal to, okay, or t is equal is the tension. What is the thrust on the pulley? Thrust here, T, total 2T. So thrust T is equal to 2 into T, that is equal to 4 m1 m2 by m1 plus m2 into G plus A. Okay? Now, if I have a spring balance here, what is the reading of the spring balance? Remember, the spring balance always gives you the weight of the body, or the thrust on that. So what is the thrust here? So much. Now if I stand on a spring balance, or if I'm made to hang from a spring balance, suppose I'm 80 kilos, the reading is 80 kilos, but what it shows, it should actually show is the force, tension 80 into that T, whatever T it has. So similarly, the mass of all that into G is actually 4 into all this. So whenever they ask reading of the spring balance, divide with the G. So reading of spring balance, divide with G. So this whole thing, divide with G means what do you? 4 m1 m2 by m1 plus m2 into, that is the answer. Wherever you come across. I am not discussing the springs here, only the spring balance. Both are of course one and the same, but since you are absolutely familiar with the spring balance, I am using it. Now look, suppose I am taking a case like this. M2, this is M1, okay? What is the reading in the spring balance? What is the reading in the spring balance? Now, horizontally if you keep the spring balance, it doesn't show any reading. If I am pulling that spring balance in any direction, it will keep on moving, it will be accelerating, but it will not show any reading unless it has certain mass, the spring has mass. We assume that there is no mass of the spring balance here. So its mass is 0. So if I am holding it and pulling it, look at the case of a string that I have shown you. T on F on this side, F on this side. If I pull it, the actual tension there is T. The spring balance also will show if it is T here, if it is T here, it will exactly show the reading as if it is T and T, T by G is the reading. Now we have to get that but first of all, I presume is accelerating up, this is accelerating, down and this is accelerating up. Even if I take a T1 or T2 here, let me take T1 here, but the moment I take T1 and T2, T2 minus T1 is equal to 0 into A. So T1 is equal to T2 because I have neglected the mass of the spring balance. Therefore, your T2, T1 are one and the same. I hope this point is clear. You can't directly take T on both sides and then do it. Two different strings, right? Because its mass is 0, I am now taking T2 minus T1 to be equal to 0. Hence, T1 is equal to T2 is equal to T. Now, the rest is, this is like your spring balance, Atwood machine. That is the tension. So, tension is like this. So, with the same tension, I am pulling that spring, then it will show you a reading. What is the reading? T by G. So, the reading is now this is very, very important. Presume that M1 is equal to M2. What do you get? 2m square by 2m. Therefore, it will exactly show M. People call it as M1 plus M2 by 2. Absolutely wrong. In fact, M1 M2 by M1 plus M2 is incidentally called reduced mass, a concept that we will probably discuss in detail in center of mass, not at this stage. It is twice the reduced mass, that is the reading of the spring balance. Okay, whenever you have a situation of this kind. I hope this is clear to you. Okay. Now, if I take another case, there is a baby monkey holding on to mother monkey's tail. Okay? And this is trying to move up with A relative to the tail. Relative to the tail. What is the tension here? Suppose if I want to know, let this tension be T2, this tension be T1. Presuming that this is stationary. So how do you write it? FBD will take you to T1, M1G. In this it is T2. It is stationary. Supposing I am taking this is moving up with, let us call it as A, okay? A1, suppose. If it is also accelerating, then what do you write? Or T1 minus T2 minus M1G is equal to M1A1. He is already given A1 there. And here how do you write what is FBD? Baby monkey, how do you draw? This is T2 below only M2G. Okay? Since this is accelerating up with A1, this whole thing, pseudo force you have to take on this, and that is going to be M2A1. If it is stationary, this will not come into play. Because I took a complicated case here with A1 going up, you will get M2A1 downwards. And once you take pseudo force, you will get relative acceleration. And you say it is going up with the AR, we will call it as, or I would say A21 to be more precise. You don't have issues. So how do I write that? T2 minus M2A1 minus M2G is equal to M2A21. Remember in this, A1 is given to us, therefore the only variables are T1, T2, and it is moving with certain relative acceleration that is also given. Therefore, A1 is known, A21 is known. You can find out what is the tension in the tail, what is the tension. Sometimes they say, see, this is how if it is moving up. Now, if I take this as plus or minus, that means it may be accelerating up or it may be accelerating down. So in which case, what do I do here? Based on that, we will take it. You got the point? Similarly, even up I said, how many possibilities do you get there? Plus or minus A1. So, plus when you take two possibilities, minus you take two possibilities. There are four embedded problems in this. Each one you can take and solve. Each one. So you will get one maximum and minimum. Now they may say this cannot hold more than a particular tension. So what could be the maximum A1 or minimum A1? Then you fix your T1 and find out. Because you got T1 value, you got T2 value, substitute in that, and then you will get the answer. Easily you can do it. I'm sure of it. So for example, because these two are known to us, now T2 gets cancelled. So T1 is equal to you bring this onto this side, M1 into G plus or minus, because I'm adding these two, this one will go M2 into A1. A1 plus G plus or minus. Now all possibilities I have given in this. And you can similarly find out what is T2, you will directly get it. What is T2? M2 into A1 plus G. I'm purposely giving this to you. Any number of possibilities you can work on with this. And then if they say T1 cannot be more than say 200, take T1 200, they'll give a relative acceleration, you can find out what is A1. A1 you will get in two cases. So one is minimum, other is maximum. That's how you will get it. I hope the model is clear to you. How to work out problems based on that is clear to you. Now, fine. I think I'll put a stop to this here. Probably in my next lecture, I will get into the other force, like normal force. Okay, thank you.